This is a brain scan, or rather, it is a scan where a brain should be. The young man whose skull this is earned a first-class honors degree in mathematics from the University of Sheffield. His IQ measured 126. He was, by any external measure, a perfectly intelligent, functioning human being. His brain had been compressed to a thin shell by decades of accumulated cerebrospinal fluid. His cranial cavity was, as his neurologist put it, filled with water. How is this possible? Science is still working on the answer. Act 1. John Lorber's discovery. Dr. John Lorber was a pediatric neurologist at the University of Sheffield who specialized in hydrocephalus, a condition in which cerebrospinal fluid accumulates in the skull, compressing the brain from the inside. Over the course of his career, Lorber documented hundreds of patients. What he found in a subset of them defied everything neuroscience thought it knew. There is a young student at this university who has an IQ of 126 and has gained a first-class honors degree in mathematics and virtually no brain. When we did a brain scan, we saw that instead of the normal 4.5 centimeters of brain tissue, there was just a thin layer of mantle measuring a millimeter or so. Act 2. The science and the mystery. Modern neuroscientists continue to review Lorber's original data alongside contemporary imaging. Lorber classified his patients into 4 groups. In the most severe category, those with more than 95% of the cavity filled with fluid, roughly half had IQs over 100. The cases were controversial when published and remain debated today. Some researchers question the imaging precision of that era. Others suggest that what remained of the brain tissue had undergone extreme compression and extreme plasticity, concentrating function into whatever neural material survived. The honest answer is that we still don't fully understand these cases. They challenge our most basic assumptions about how much brain you need to think. The brain appears to have redundancies and organizational capacities that we haven't mapped. Science textbooks are being rewritten. Act 3. What it means. Lorber's patients raise questions that the field is only beginning to properly frame. If a brain compressed to a thin membrane can support intelligence, what does that tell us? Is function localized in specific tissue or distributed across patterns? The emerging answer appears to be both, and neither. The brain is more redundant, more flexible, and more mysterious than our models have accounted for. Lorber's patients are not anomalies to be explained away. They are data points pointing toward a deeper truth we haven't yet fully grasped. John Lorber died in 1996. His files, his scans, and his unanswered questions remain. The young mathematician lived a normal life. According to the science of his time, he could not possibly have been doing what he was so clearly doing. Some mysteries demand a larger question. For more stories of medical pioneers and the paradoxes of the human mind, visit us at unbedsidemanners.com.